Welcome, viewers. Today we will be looking at a very important topic, which is factorials. Like you can clearly see in this particular slide, we have three shapes and they are arranged in 6 different ways. 3 factorial is equals to 3 times 2 times 1, and that is equals to 6. We will be seeing more as we go on in this video. So we are talking about factorials. Factorial is the product of all positive integers less than or equals to n. It is the product of all positive integers less than or equals to n. For instance, you have n factorial. The exclamation mark is the factorial. So you have n factorial, and that's simply equals to n itself, and then n minus 1 times n minus 2 times all the values that are less than n, positive integers, up till 1. So we are looking at factorials. N factorial, which is equals to n times n minus 1 times n minus 2 times all the values less than n, positive values, up till 1, and whole numbers. Now you have 6 factorial, given the above definition, will be 6 times 5 times 4 times 3 times 2 times 1. That is, you start with 6 itself and end with 1. And that gives us 720, because 6 times 5 is 30, 30 times 4 is 120, 120 times 3 is equals to 360, and 360 times 2 is 720. Now 5 factorial will be 5 itself times 4 times 3 times 2 and times 1, and that should give us 120. So what we say is that 5 times 4 is 20, 20 times 3 is 60, and 60 times 2 is 120, and 120 times 1 is 120. Now let's look at 4 factorial, which is simply 4 itself times 3, which is 12, 12 times 2, 24, and 24 times 1 is equals to 24. So that's just a simple way of carrying out factorials. Now let's also look at 3 factorial in this particular case. That is to say, 3 times 2 times 1, 3 times 2, 6, 6 times 1 is 6. 2 factorial will simply be 2 times 1, which is equals to 2. And 1 factorial will simply be 1 itself. And the last one will surprise you, which is 0 factorial, and that is equals to 1. In our subsequent videos, we'll be showing how 0 factorial is equals to 1. Just take note of that. Now, we will be carrying out this exercise 5 factorial over 3 factorial. 5 factorial divided by 3 factorial. So what is 5 factorial? On the top, which is the numerator. So we have 5 times 4 times 3 times 2 times 1, like we know. And then 3 factorial is simply, that is at the denominator, we have 3 times 2 times 1. So if you look at the top and the bottom, you see that there is something that is common. 3 times 2 times 1 is common at the top, and 3 times 2 times 1 is also common at the base, so they can cancel out. So what we're saying in essence is that 3 factorial at the top is also common to the 3 factorial at the base. So this cancels out 1 divided, and then this cancels out 1. So we're left with 5 times 4, which is equals to 20. So this tells you and I that we could simply have expressed the above as 5 factorial divided by 3 factorial will simply be equals to 5 times 4 times 3 factorial, that is the numerator, divided by 3 factorial at the denominator. And then therefore the 3 factorial simply cancels out just as we had done before. So we have 5 times 4, and that is equals to 20, which is similar or the same as what we did above. What we just did below is to rewrite the question in terms of factorial. So we will quickly look at another question, 10 factorial divided by 12 factorial. If we look at the top expression, you have 10 factorial, and then you divide it by 12 factorial. Remember that 12 factorial is the same as 12 times 11 times 10 factorial. That is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But remember that your 10 factorial above is also the same and as contained in the 12 factorial, such that your 12 factorial can now be expressed as 12 times 11, then times 10 factorial. So you have 10 factorial common to the numerator and the denominator, so they can simply cancel out. So divide through by 10 factorial, you have 1 there and 1 there. So you simplify, you have 1 divided by 12 times 11, which is 132. Let's look at another question. We have 8 factorial divided by 6 factorial divided by 2 factorial. If you look at the denominator, you see your 6 factorial here. Remember that we can express 8 factorial as 8 times 7 and times 6 factorial. You know we have 6 factorial here, so they can simply cancel out. So when that happens, you have 6 factorial here 1, and then 6 factorial here 1. So you're now left with 8 times 7, and then divided by 2, and then 2 here 1, 2 here 4. So you have 4 times 7, which is equals to 28. So let's look at these 3 shapes, and let's see possible ways in which these 3 shapes can be arranged. You have 3 shapes here. One shape, another shape, and then another shape. So one is yellow, one is purple, and then one is green. So let's see how many ways we can arrange this. So let's keep this first arrangement as the first arrangement, and then we move below, and then we still keep the yellow constant. So it therefore means that if we are going to arrange this and this, we will now put the green first this time around, and then we will put the purple next. So that's the first 2 arrangements we've done. Now let's try another arrangement. This time we will put the purple first. When we put the purple first, we have the option of either putting the yellow or green. So let's put green first, then yellow will come next. Then let's also keep the purple constant this time around. You remember above we had the green coming before the yellow. So this time let's put the yellow first before the green. So that's how it plays out. So now we've kept the yellow constant in 2 places. We also kept the purple constant. Let's see how we can make the green constant. So we have the option of putting either the yellow or the purple. So in this one, we can put the purple first, and then the yellow will come next. And then when we keep the purple to the next side, it will now be yellow first and then purple. So what we've simply done is to arrange three shapes, that is considering the three colors or three shapes, in different ways. So this is the first way, and this is the second. This is the third arrangement. This is the fourth arrangement. And then this is the fifth arrangement. And then this is the sixth arrangement. So we have three shapes and we have arranged them in 6 different ways. We have three shapes, just as we can see, and we were able to arrange them in 6 ways. And that is simply expressed as 3 factorial, 3 shapes, 3 factorial, which is 3 times 2 times 1, and that gives us 6. If we had 4 shapes, your guess is as good as mine. If we carry out the 4 factorial for the 4 shapes, we'll have 24 different ways. Why don't you try it on your own and see what you get? So we will be talking about permutations. All we have been doing is to lay a foundation, having a knowledge of factorials, and that will help us in 2 topics among others, one being permutations and another being combinations. We won't be going deeply into those topics. We'll just lay a foundation based on simple definition. Now, what is permutation? What are permutations? They are simply represented in that mathematical form, NP R, which is n factorial divided by n minus r factorial. So that is the mathematical expression for permutations. We see that they are expressed in form of factorials. So like I said earlier, our looking at the factorials was basically laying a good foundation for us to understand topics like permutations, combinations, and several others. Now, what is a permutation? Or what are permutations? An arrangement of objects in which order is important. It's got to do arrangement of objects taken into consideration order. Now, another definition is ordered arrangement of R items. You can see R items out of a list of n items. Out of a list of n items. So it's R items out of a list of n items. So that's just the mathematical expression above. Now this time around, we'll also be looking at combinations. Combinations also is expressed as n combination R, NCR, which is simply equals to n factorial divided by R factorial and also n minus R factorial. Now, what's the definition of combination? Combination is simply the arrangement of R items, like we can see here, R items, out of a list of n where the order does not matter. In this particular case, the order does not matter. So what we have simply done is to look at factorials and then introduced permutations and also combinations, just their mathematics expression, or rather their mathematical expressions and also their definitions. In subsequent videos, we will be looking at more details, and we will also be looking at more examples in terms of factorials. Thank you. If this video has been useful and has added value, kindly subscribe, kindly like, and share.